Hi students, the topic of this video is Ohm's Law. Ohm's Law states that in metallic conductors at a constant temperature and in a zero magnetic field, the current flowing is proportional to the voltage across the ends of the conductor and inversely proportional to the resistance of the conductor. He set a simple circuit like this with batteries with a voltage of V and a resistor with a value of R, and use an ammeter measuring the current. When he increased the voltage of the battery by, let's say, the number of batteries, he observes that the current also increases proportionally. So you see that the slope of this line is constant. So when we take the slope, you see that the potential difference to the current is constant. So what is the constant value that doesn't change in the circuit is the resistance. So the potential difference over the current gives us the resistance. So we have the formula. The potential difference is equal to the current times resistance, or when you take the current is equal to potential over resistance, or when you take the resistance is equal to potential over the current. The resistance is indicated by the letter R, and it is measured in ohm and have this symbol omega. Voltage is the unit is volt, and we use the symbol V for volt, and current is the electric current. The unit is ampere. The symbol for the current is I, and the symbol for the unit is A. Let's apply the Ohm's law into a simple example. Let's find the values read on ammeter and the voltmeter. You see that there is a battery with a voltage of 16 volt, and we have only one resistor with a value of 6 ohm. So from this, the current is equal to voltage over resistance 12 over 6, which is equal to 2 ampere. So you see the ampere is measuring the current passing from the resistant with the value of 2 ampere. Now, you can find the value of voltage read from the voltmeter because there is only one appliance that will take the all energy of the battery. So you can say directly that this is equal to the voltage of the battery. Or you may calculate the voltmeter reading will be equal to the current times R. The current passing through the 6 ohm is equal to 2 ampere. The value of the resistor is equal to 6 ohm, so it should be equal to 12 volt. Now let's see how the resistors are combined, one in series. If the resistors are at the same line, so we can say that they are connected in series. We have here three properties. The first property is current. The current taken from the battery will pass from the first resistor, and then from the second one, and then from the third one, and come to the negative pole of the battery. So the first property, the current passing from each resistor should be equal to each other, which is equal to the current in the main circuit. Now, as the voltage is equal to the current times the resistor, they have the same current. So the voltage across each resistor will depend on its resistance values. So the voltage taken from the battery should be equal to the voltages across each resistors. In combining and finding the equivalent resistors, the total equivalent resistance will be equal to the sum of each resistors R1 plus R2 plus R3. In combining the resistors in parallel, we take the let's say this point A and this point B, the potential difference between A and B will be equal to the potential of the battery V. So you see that this point, there's no appliance has the value of A potential, this has A potential, no appliance for B potential, no appliance B potential. So you see that all of the resistors are between the same points AB, which is equal to the point of the battery. So for the first property, I can say that the potential difference of each resistors will be equal to each other, which is equal to the potential difference of the battery. The current coming from the battery here will be divided into two. One will go to, let's say, I1 to the resistance R1, and the second one will go to the resistance R2 as I2. So this is a junction point. The current coming into the junction will be equal to the currents going out of the junction. So as a second property, I can say that the currents at the branches will be equal to their sum, the main current. The total resistance will be calculated like this. 1 over R equivalent is equal to 1 over R1 plus 1 over R2 give me the total resistance. Let's do an example according to the next figure. Let's find the current in the main circuit passing through each resistance and the potential difference between KL and LM. Now first let's find the total resistance. The sum of 6 and 6 ohm, they are in parallel, so 1 over R equivalent will be equal to 1 over 6 plus 1 over 6, which is equal to 2 over 6, 1 over 3. So their sum is equal to 3 ohm. 3 ohm is connected to 12 ohm in series, so their total will be equal to 15 ohm. So for A, the current in the main circuit will be equal to the total potential over the total resistance. The total potential is the potential of the battery 10 volts over the total resistance 15 ohm, which is equal to 2 over 3 amperes. Now 2 over 3 ampere comes here. It will divide into 2 equally because the resistance are equal. So 1 over 3 ampere will go up, 1 over 3 ampere will go up, then they will combine here and pass as 2 over 3 ampere. The current passing from 12 ohm will be equal to the current in the main circuit because it is in the main circuit. So for B, the current passing from 6 ohm will be equal to 1 over 3 ampere. The current passing from 12 ohm will be equal to 2 over 3 ampere. Now let's find the potential difference. The potential difference between K and L will be equal to the current passing from KL times the total resistance between KL. Current passing through here is 2 over 3 ampere. The total resistance between the points KL is 3 ohm, so it will be equal to 2 volts. For LM, you can say the current passing from the points LM times the resistance between LM. The current passing through here is 2 over 3 ampere and the resistance is 12 ohm, so it will be equal to 8 volts. Be careful here that this have the total potential of 10 volt, which is equal to the voltage of the battery. Another example, here we have the voltmeter reading 10 volt. The electromotor force, the potential of the battery is asked. So I can find the current passing from 2 ohm the current is equal to potential over resistance, which is equal to 5 ampere. Now I'm going to find the total resistance. Now 2 and 2, they are in parallel, so as they are equal, I can divide into the branches, which is equal to 1 ohm. 1 ohm and 2 ohm are in series, so the total resistance in the circuit is equal to 2 plus 1, which is equal to 3 ohm. The total current, the current in the main circuit is equal to 5 ampere, so the electromotor force of the battery from the current times resistance, 5 times 3, which is equal to 15 volt. In this example, the currents passing through each resistors are asked. Let's give the voltage of the battery as 18 volt. Now it may seem a little bit complex, so let's find which one are in the main circuit and which ones are connected as parallel. Now if I label this point as A and this point as B, you see that take the potentials A and then take the potentials B. So you see that 18 ohm are between the points AB, 9 ohm between the points AB, 6 ohm between the points AB. So all these three resistors are in parallel. So I can redraw the circuit like this. K, M, and P are in parallel, and L and N are on the main circuit. So first let's combine these parallel values. The 1 over R total is equal to 1 over 18 plus 1 over 9 plus 1 over 6. So I have 6 over 18, which is equal to 1 over 3. So the total resistance is equal to 3 ohm. 3 ohm, 1 and 2 are in series, so the equivalent resistance which will be equal to 3 plus 2 plus 1, which is equal to 6 ohm. So the current taken from the battery will be equal to the total potentials over total resistance, which is equal to 18 volt over 6, 3 ampere. So 3 ampere pass from 2 ohm, it comes here, so will be divided into 3. So if I comes here, so they have the same potential, so current will be divided inverse proportion to the resistance value. So 2I will come here and 3I will come here. As a combination of the current will give me the current in the main circuit. 6I is equal to 3 ampere, so I is equal to 1 over 2 ampere. So from 18 ohm, 1 over 2 ampere current pass, from 9 ohm, 1 ampere current pass, and from 6 ohm, 3 over 2 ampere current pass. They combine, and as 1 ohm also on the main circuit, the current passing through it is 3 ampere. In short circuits, if 2 points in a circuit are connected by some component or conductor having a resistance of 0, the 2 points are said to be short-circuited, or that there is a short circuit present. Under these conditions, a larger current will flow due to the reduction in resistance, and there will be no potential difference between the ends of the short circuit. Now, let's do these examples. Let's say this has a potential K and this has a potential L. You see that there is a short circuit here, so this point has also a potential K. So these two resistors are between the points KK, which has no potential difference. So there will be short circuit and only this lamp will shine. In the second figure, so let's again put this point as K and this point as L. There's a short circuit here, so this has a potential of L. So these two lamps are between the same points with no potential difference, so they will not work, only this lamp will shine. In the diagram C, let's put this K and this L. I can't go further, so this is another point, let's say M. Here we have a short circuit, so this has also potential M. So you see that this lamp is between M and M with no potential difference, so it will not work, and only these two lamps will shine.